The tunnel you're looking at is no ordinary tunnel. This is the world's largest undersea tunnel and engineering marvel that stretches for 50 kilometers and connects two countries once thought to be forever divided by the sea. Engineers often call it the seventh wonder of the modern world, and the reason is simple. Its construction was one of the most daring and dangerous projects ever attempted. Imagine working 250 feet beneath the seabed, with the weight of the entire English Channel pressing down above you. One wrong calculation, one tiny crack, and in a matter of seconds, the tunnel could flood burying machines and workers forever. Yet despite these unimaginable risks, more than 13,000 workers joined hands to bring this project to life. Today, we're going to uncover the full story of the Channel Tunnel, also known as the Eurotunnel, a story of history, politics, struggle, and one of the greatest feats of human engineering. How it all began? Let's rewind history around 13,000 years ago when the last ice age was ending. Melting glaciers raised sea levels and flooded the land bridge that once connected today's England with mainland Europe. The result was a natural barrier, a stretch of water we now call the English Channel. Although wide, this channel narrows at one point to just about 33 kilometers between Dover in England and Calais in France. For centuries, this narrow strip was both a connection and a shield. Throughout history, many dreamed of bridging this gap. But attempts often failed, technology simply wasn't ready, and human lives were lost. Even Napoleon once considered it. And later, during World War II, Hitler secretly planned to dig a tunnel beneath the channel to invade England. That project, however, never even began. For England, this water barrier was always a blessing. It kept enemies at bay, from Napoleon's armies to Hitler's Luftwaffe. The cold, stormy channel became England's natural defense. But times changed. By the late 20th century, war gave way to trade. Europe was prospering, and nations were seeking connection, not separation. Finally, in 1986, France and England agreed. It was time to remove the divide and build a tunnel. The plan was bold. Not one, but 3 parallel tunnels would be dug beneath the sea. 2 for high-speed trains carrying passengers, cars, and trucks, and 1 smaller service tunnel used for maintenance and emergencies. The tunnel would stretch 56 kilometers in total, with 38 kilometers running directly under the sea, the longest undersea section anywhere in the world. The English terminal would be in Folkestone, and the French terminal in Calais. Teams from both sides would dig towards each other until they met in the middle. It sounded impossible, and in fact, many believed it would fail before it even started. But 10 major engineering companies formed a partnership and accepted the challenge. The machines behind the miracle at the heart of the project were massive tunnel boring machines, or TBMs. These were not ordinary machines. Since no tunnel of this scale had ever been built, such machines didn't even exist. So, a custom-built TBM was designed in Seattle, Washington, by the Robbins Company. Once completed, it was 800 feet long, weighed 1,500 tons, and had a diameter of 50 feet. Its giant rotating head, equipped with tungsten carbide blades, could slice through rock and chalk with immense power. Behind it, a conveyor belt carried crushed rock and soil away to waiting service trains, which then transported debris out of the tunnel. But there was a catch. If water seeped in while boring 250 feet below the seabed, the pressure could crush everything instantly. Surveys revealed chalk layers on the English side that would help keep water out, but the French side was riddled with cracks. To deal with this, engineers designed a different kind of TBM-1 that could withstand the pressure of a submarine. Each machine had to be disassembled, lowered piece by piece underground, and reassembled in position. This process alone cost millions and took months. Challenges beneath the sea by 1988, construction was in full swing. But now came another challenge: what to do with the mountains of debris. On the English side, more than 4.9 million cubic meters of chalk was removed and used to create a brand new piece of land today called Samphire Hoe, a country park along the coast. On the French side, the softer clay-like soil was dumped to create artificial lakes near Sangatte. As boring progressed, workers installed 750,000 giant concrete segments, each weighing up to 40 tons, to line the tunnel walls. This reinforced structure was so strong that the same amount of concrete could have built 8 Burj Khalifas. Still, precision was everything. If the two tunnels didn't meet exactly under the sea, the project would collapse literally and financially. To ensure accuracy, engineers used advanced laser guidance systems. These lasers, linked wirelessly across the channel, constantly adjusted the machine's positions by tiny fractions of a degree. In the final 100 meters, the TBMs were stopped. Engineers drilled a pilot hole and sent a steel rod through to confirm alignment. The result? The two tunnels were off by only 10 inches well, within acceptable limits. Sacrifice of a giant, but there was another problem. Once the tunnels were lined with thick concrete, their diameter shrank to 46 feet smaller than the TBMs themselves. That meant the machines could no longer be removed. The solution? A TBM had to be sacrificed? The English machine was tilted downward, buried deep into the ground, and left there forever. The French TBM, meanwhile, was dismantled and pulled out. A historic connection. Finally, in December 1990, workers from both sides broke through the last wall of chalk. For the first time in 13,000 years, England and mainland Europe were physically connected again. One worker from England and one from France shook hands, exchanged flags, and marked the historic moment that changed Europe forever. After years of finishing touches and safety checks, the Channel Tunnel officially opened on May 6, 1994. The legacy of the project cost the equivalent of £12 billion in today's money. It involved over 13,000 workers, and sadly, 10 lives were lost during construction, but the result is breathtaking. Today, around 60,000 people use the tunnel every single day. It carries 4,600 trucks, 7,300 cars, and 140 coaches across the channel, plus high-speed Eurostar trains that whisk passengers between London and Paris in just over 2 hours. The Channel Tunnel is more than just an engineering project. It's a symbol of connection, perseverance, and what humans can achieve when they dare to take on the impossible. And that's the incredible story of the world's largest undersea tunnel. I hope you enjoyed this deep dive into history and engineering. Don't forget to like, share, and subscribe to Zem TV for more amazing stories. Thank you for watching, and I'll see you in the next video.